Hello everyone. In this video, we are going to discuss about chapter number 5 Arithmetic Progressions of class 10 Maths, and we will be discussing about arithmetic progressions in this video, and after that we will be discussing some questions based on this topic. Now you see, consider a list of numbers given here. The first one is 1, 2, 3, 4. Second list of numbers 100, 70, 40, 20, etc. Then the third list is minus 3, minus 2, minus 1, 0, etc. And the fourth list and fifth list are given here. So you see, each of the numbers in this list is a term. Okay, each of the numbers in this list is a term. So you see, 1 is a term, 70 is a term, minus 2 is a term, 3 is a term, minus 1.0 is a term. Okay, now in each of these lists, 4 terms are given. Okay, what will be the next term or what will be the next number? Observe the list. They follow a pattern or a particular rule now. That is, you see, the first list. See the first list 1, 2, 3, 4, etc. So what about the fifth number? What about the fifth term? You see, in the first list of numbers, each term is one more than the term preceding it. That is, each term is one more than the preceding term. That is, if you consider the term 2, its preceding term is 1. So 2 is 1 more than 1, no, 1 plus 1. Similarly, if you consider this term 4, its preceding term is 3. So 1 more than 3, that is 3 plus 1, 4. So in the first list of numbers, each term is 1 more than the term preceding it. Okay, that is, each term is 1 more than the preceding term. So what will be the next term? What will be the fifth term? 4 plus 1. That is, fifth term will be 5. Now, consider the second list of numbers. See, in the second list, 170, 40, 10, etc. So, in the second list, each term is 30 less than the preceding term. Right, because you see, the second term is 70, its preceding term is 100. So, 30 less than 100, that is 100 minus 30 is 70. If you consider this term 10, its preceding term is 40. So 30 less than 40 means 40 minus 30, which will be 40 minus 30 is 10. Then what about the fifth term? It will be 30 less than 10, that is 10 minus 30, which is equal to minus 20. So minus 20 will be the next term. Okay, now consider the third list of numbers, minus 3, minus 2, minus 1, 0. Here, each term is obtained by adding 1 to the term preceding it. Okay, that is, you get minus 2. If you consider minus 2, its preceding term is minus 3. So, when you add plus 1 with minus 3, you will get minus 2. Okay, similarly, if you consider this term 0, its preceding term is minus 1. So, adding 1 to the preceding term, that is adding 1 to the minus 1, will give you 0. Okay, so what about the fifth term? Fourth term is 0. So 0 plus 1, 0 plus 1 is 1. So 1 will be the fifth term. Okay, similarly, if you consider the next list of numbers, that is the fourth list of numbers, all the terms in this list are 3. 3, 3, 3, 3. So each term is obtained by adding or subtracting 0 to the term preceding it. That is 3 plus 0, 3, 3 plus 0, 3, 3 plus 0, 3, or 3 minus 0, 3, 3 minus 0, 3, 3 minus 0, 3. Okay, so you see, every terms, they actually follow a particular pattern or a rule. Okay, now let us see the fifth list of numbers. Here, minus 1.0, minus 1.5, minus 2.0, minus 2.5. So here you see, each term is obtained, that is except the first term, each term is obtained by adding minus 0.5 to the term preceding it. That is, each term is obtained by subtracting 0.5 from the term preceding it. That is, if you consider the second term minus 1.5, its preceding term is minus 1, minus 1.0. And if you add minus 0.5 with its preceding term, that is with minus 1.0, you will get minus 1.5, that is the second term. Okay, similarly, if you consider this term minus 2.5, its preceding term is minus 2.0. When you add minus 0.5, you will get it as minus 2.5. Okay. So, here in all the 5 lists of numbers, successive terms are obtained by adding a fixed number to the preceding terms. See, subtraction is also a kind of addition, no? That is in the 5th list, you see, you will get minus 1.5. That is when you consider its preceding term minus 1.0. When you add minus 0.5 with its preceding term, you will get minus 1.5. Okay, see, this can also be written as minus 1.0 is the preceding term of minus 1.5. And when you subtract 0.5 from it, you will get minus 1.5. So you see, minus 1.0 minus 0.5, this is a kind of subtraction. Okay, that can also be written as what? Minus 1.0 plus minus 0.5. So you see, subtraction is also a kind of addition. So here in all the 5 lists of numbers, successive terms are obtained by adding a fixed number to the preceding terms. Okay, so such a list of numbers that is said to form an arithmetic progression or AP. Arithmetic progression, its short form is AP. So you see, AP is, that is arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term, except the first term. That fixed number, that is actually called as common difference of the arithmetic progression or common difference of AP. See, this common difference, that can be positive, that can be negative, and that can be 0. That is, in the first list, the common difference is positive, that is, it is plus 1, right? That is when you add plus 1 with its preceding term, that is 2 plus 1, 3, 3 plus 1, 4. So here the common difference is plus 1, it is positive. In the second list, you see, we are actually subtracting 30 from each term, preceding term. That is, it is a kind of, you see, when you consider this 70, its preceding term is 100. Okay, so this is like 100 plus minus 30, which is 100 minus 30, which is equal to 70. Okay, so here we are adding minus 30 with the preceding term and you are getting the next term. So here the common difference is minus 30, that is common difference is negative. Okay, similarly in the fourth list, 3, 3, 3, 3. Okay, here it is like 3 plus 0, 3, 3 plus 0, 3. So here the common difference is 0. Okay, so you see, arithmetic progression or AP, it is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. That fixed number, that is actually called as common difference of AP. That common difference can be positive, negative and 0. Now, let us denote the first term of an arithmetic progression, that is AP by A1, second term of AP by A2, third term of AP by A3, etc. The nth term of AP is denoted by AN. And let us denote the common difference by small letter d. So, small letter d is denoted to represent common difference of AP. A1 is the first term of AP, A2 is the second term of AP, A3 is the third term of AP, etc. AN is the nth term of AP. Then this AP becomes A1, comma, A2, comma, A3, etc. AN. Okay, so AP becomes A1, A2, A3, etc. AN. There will be n terms. And A2 minus A1. Okay, that will be equal to what? That will be the common difference D. Similarly, A3 minus A2. That will be the common difference D. Similarly, if you consider the nth term, that is An minus the term before that nth term will be what? An minus 1. Because you see here, third term is A3. So, second term is actually A3 minus 1. No, third term is A3. So, second term is A3 minus 1. That is A2. Similarly, nth term is An. So, the term just before that will be An minus 1. Okay, this will also be equal to the common difference D. So, in our first list of numbers 1, 2, 3, 4, etc., this actually represents an AP. Here, A1 which is the first term is 1, A2 which is the second term is 2, A3 which is the third term is 3, etc. Okay, and here what about the common difference? Common difference D will be equal to A2 minus A1 which is 2 minus 1 which is equal to 1. Or common difference D is also equal to what? A3 minus A2, that is equal to A3 is 3, A2 is 2, so 3 minus 2 which is again 1. Okay, so this actually represents an AP. And if we take the first term as small letter A, suppose I take the first term as, that is A1 as small letter A. Okay, then what about the second term? If I take the first term as A, then second term A2 will be equal to A plus D. Right, here you see the first term A1 is 1. So, second term A2 is actually that A1 plus common difference D. A1 is actually 1 plus common difference D is 1. So, 1 plus 1, 2. Okay. So, if first term is A, second term A2 can be written as A plus D. Okay, similarly, third term A3 can be written as A plus D is the second term plus common difference D. Right, here you see in this list, the third term A3 is actually equal to 3. This 3 is actually 2 plus 1. Right, what is this 2? 2 is actually A2, so A2 plus 1. So, A3 is A2 plus 1. Similarly, here A3 will be A2, that is A plus D, plus 1 is the common difference, so D. Okay, so A3 is actually what? A plus D, which is 2D. Okay, similarly, what about the fourth term? Fourth term will be A plus 3D. Okay, similarly, you can have n terms. So, A1, A2, A3, A4, if it represents an AP, and if you consider this first term as A, then second term can be written as A plus D, where D is the common difference. A3 can be written as, third term can be written as A plus 2D, fourth term can be written as A plus 3D, etc. So, this, that is A plus D, A plus 2D, A plus 3D, etc. This actually represents an AP, where A is the first term and D is the common difference. And this is actually known as or called as the general form of an arithmetic progression. Now, if we consider this AP 1, 2, 3, 4, etc., there can be infinite number of terms. We cannot say what its last term is. Such an AP is called as infinite AP. Okay, such arithmetic progressions do not have. So, for an infinite AP, we cannot say what its last term is. Such arithmetic progressions do not possess last term. Now, let us consider one example. That is, what will be the total savings in rupees after every month for 10 months when rupees 50 are saved each month? What will be the total savings in rupees after every month for 10 months when rupees 50 are saved for each month? Saved each month. That is, first month rupees 50 will be saved. Second month again 50, so 50 plus 50, 100. Third month again 50, so 100 plus 50, 150 is the total savings now. Now fourth month 150 plus 50, which is 200, is the total savings now. Fifth month 250 will be the total savings. Sixth month 300 rupees. Seventh month 350 rupees. Eighth month 400 rupees. Okay, ninth month 450 rupees, and 10th month the total savings will be 500 rupees. That is, when rupees 50 are saved for each month, saved each month for 10 months, the total savings after 10 months will be 500 rupees. So see, this also represents an AP, no? That is, first term is 50, second term 100, then 150, 200, 250, etc. 500. Okay, that is in between 250 and 200, all other terms are there. So this also represents an AP, arithmetic progression. And its first term, A is equal to 50. What about its common difference D? Its common difference D is 100 minus 50, which is 50. So this actually represents an arithmetic progression AP. So you see, in this AP, we have only a finite number of terms. That is, from 50 to 500, only 10 terms are there. So you see, the first term is 50 and the last term of this AP is 500. Such an AP which has only a finite number of terms, they are actually called as finite AP. So for an infinite AP, there won't be any last term, but for a finite AP, there will be a last term. It will have only a finite number of terms. Now you see, if first term of an AP is 6 and common difference D equals 3, then AP will be what? First term is 6, second term will be what? 6 plus 3. Okay, that is 9. Third term 9 plus 3, 12. Fourth term 12 plus 3, 15, etc. Okay, similarly, if the first term of an AP is 6 and common difference D is minus 3, what about the AP? First term 6, common difference is minus 3. So to get the next term, we have to add this common difference with its preceding term. So to get the second term, its preceding term, that is first term is 6, add the common difference minus 3 with it. So 6 plus minus 3 is actually 6 minus 3, which is 3. So second term is 3. Okay, now to get the third term, its preceding term is second term 3. Add common difference with it. So this is like 3 minus 3. 3 minus 3 is 0. Okay, now to get the fourth term, its preceding term is 0. So add the common difference minus 3 with it. So this is like 0 minus 3, which is equal to minus 3. Okay, etc. So you see, in an arithmetic progression in an AP, every succeeding term means any term which immediately follows it. So every succeeding term is obtained by adding common difference D to the preceding term. Okay, succeeding term means any term which immediately follows the preceding term. So D can be found by, that is, common difference D of an AP can be found by subtracting any term from its succeeding term. That is, for example, for the list of numbers 6, 9, 12, 15, the first term of this AP, A equals 6. To get the common difference D, what you want to do? You just want to subtract any term from its succeeding term. That is, if you consider the term 9, its succeeding term is 12. So subtract 9 from 12, that is 12 minus 9, which is equal to 3. Okay, or if you can even consider this 12, its succeeding term is 15. So subtract 12 from its succeeding term, that is 15 minus 12, which is equal to 3. So for this list of numbers, first term is 6 and common difference is 3. Okay, that is the difference of any two consecutive terms. Now for the list of numbers 6, 3, 0, minus 3. You see, if you consider this number 3, here the first term is 6. So A equals 6. To get the common difference D, if you consider this number, this term 3, its succeeding term is 0. So subtract this number from its succeeding term, that is 0 minus 3, which is equal to minus 3. Okay, similarity can also be found out by using, suppose you are considering this term 0. So its succeeding term is minus 3. So subtract this number from its succeeding term, that is minus 3 minus 0, which is equal to minus 3. Okay. So in AP, every succeeding term is obtained by adding the common difference D to the preceding term. So D can be found out by using or by subtracting any term from its succeeding term. So in general, for an AP, A1, A2, A3, etc., A4, etc., AN, we have the common difference D as AK plus 1 minus AK. AK plus 1, that is the K plus 1th term, AK is the Kth term. Okay, these are two nearby terms. Okay, so you see, common difference D can be found out by using this equation AK plus 1 minus AK, where AK plus 1 is the K plus 1th term and AK is the Kth term. That is, common difference D will be equal to A2 minus A1, because you see, if AK is A1, then AK plus 1 will be 1 plus 1, which is 2, A2. Okay, or D can be found out by using A3 minus A2. Okay, that is, you just want to take the difference between two successive terms or two consecutive terms. Okay, now if you consider, a list of numbers 1, 1, 2, 3, 5, etc. Is this an AP? See, here the first term is 1, okay. Here the difference between any two consecutive terms is not the same, no? Two consecutive terms means this 1 and 1, so difference is 1 minus 1, 0. If you consider these two terms, so 2 minus 1, 1. If you consider these two terms, 3 minus 2, 1. If you consider these two terms, 5 minus 3, which is 2. So here you see the difference between two consecutive terms in this list of numbers, they are not the same. So this is not an AP. Okay, so I hope you got an idea about the arithmetic progression AP. See, we will be discussing one exercise question given in your textbook in the next video, which will be available in the playlist and which will be available in the description as well. So you see, watch that video as well so that you get a better idea about this AP and the problems related with arithmetic progression. So that video will be available in the description box of this video. I hope the concept of AP clear to you. Thank you.